everyone, and welcome to the TDWI webinar program. I'm Andrew Miller, and I'll be your moderator. For today's program, we're going to talk about how to unlock the power of spatial analysis and data lakehouses for better business decisions. Our sponsors today are Databricks and CARTO. For our presentations today, we'll hear first from Dave Stoddard with TDWI, and after Dave speaks, we'll be joined by Michael Johns with Databricks and Matthew Forrest with CARTO. Before I turn over the time to our speakers, I'd like to go over a few basics. Today's webinar will be about an hour long. At the end of their presentations, our speakers will host a question and answer period. So if at any time during these presentations you'd like to submit a question, just use the Ask a Question area on your screen to type in your question. If you have any technical difficulties during the webinar, please click on the Help area located below the slide window and you'll receive technical assistance. Also, if you'd like to discuss this webinar on Twitter with fellow attendees, just include the hashtag TDWI in your tweets. And if you'd like a copy of today's presentation, you can locate the resource window on the bottom right of your console. And in addition, we are recording today's event. and we'll be emailing you a link to an archived version so you can view the presentation again later if you choose, or if you'd like to share with a colleague. Again, today we're going to be discussing how to unlock the power of spatial analysis and data lakehouses for better business decisions. And our first speaker today is Dave Stoddard, Senior Director of Research for Business Intelligence at TDWI. As an analyst, writer, and researcher, Dave has provided thought leadership on key topics in BI, analytics, IT, and information management for over 2 decades. Previously, he headed up his own independent firm and served as Vice President and Research Director with Ventana Research. He was the founding chief editor of Intelligent Enterprise and served as editorial director there for 9 years. With TDWI Research, Dave focuses on providing research-based insight and best practices for organizations implementing BI, analytics, performance management, and related technologies and methods. Please welcome Dave Stoddard, and with that, I will hand it over to you.
Thanks very much, Andrew, and welcome to everybody today. I think we got an exciting topic today. We do see in our research a lot of interest in spatial analysis or analytics and using geospatial data effectively for lots of different purposes. So let me just get right into it. So I'm going to talk about, just from TWI perspectives, about unlocking the power of spatial analysis and data lakehouses. So we'll talk about the importance of data lakehouses to support spatial analysis for better business decisions. So spatial analysis, I think it is a key to new data insights. And as I mentioned, we see a lot of interest in it at TDWI. As I state here, organizations wanting to get to the next level of understanding of causes, correlations, patterns, trends. So they want to know, we're trying to analyze in different ways things happen. Why did they happen? And there's often, dark, spaces there we don't know what happened. And so this is the kind of thing that can shed light on those areas to have a better geographical sense. And so it could be about customers, about partners, say in a supply chain, what may be going on there, or in manufacturing, and competitors. Certainly, it's helpful in a lot of industries to know geospatial analysis of what the competition is doing in terms of locations and marketing and other kinds of efforts that may be going on competitively. Digital transformation, a lot of organizations are engaged in digital transformation as we speak, trying to move business applications, older processes, legacy processes, typically into the cloud. And with the idea of really, this is the opportunity to modernize those systems, make them more data-driven, make data and analytics much more central to them. And so a lot of purpose is really to reduce the risks there and recognizing opportunities by using geospatial data and analytics. So again, opening up different areas that didn't really exist with the older kinds of systems, or were often in silos typically, so not really well put together. Provide context, so those ideas around the customers, the partners, competitors, to try to get information that helps explain different events that are happening, transactions, so getting a sense of, particularly in retail or even in healthcare, if you're going around to partner networks and different providers, why would they do that? What's going on? And also related people in households and things like that. Market competition, as I mentioned, fraud and abuse. It's been used extensively to get a better understanding of fraud and abuse and criminal activity that may be going on out there. So certain law enforcement, intelligence agencies very interested in using geospatial. And then too, as I mentioned, kind of to avoid surprises, those areas that you don't see, the unknowns, location intelligence can help organizations get a better sense of it through the powers of visualization. I mean, because location really goes along with being able to look at maps and look at the data on maps and be able to respond. So spatial data, it's varied and it's diverse and it's growing. Generally, what it is information about a specific location. Often it's address related, so you have to have good address information. Geocoding provides the ability to map or to match that specific latitude and longitude, so you have being able to put the different points of data together. Just some areas, it could be objects, or typically it often is objects or events within or with a location. So you're looking at a location and be able to plug in different sorts of data. Typically roads, building, property, terrain, that's kind of the traditional forms of geospatial data. You want to begin to combine location information, which would be coordinates, typically with attribute information. So you've got lots of other kinds of data sources that you want to combine with it to understand what you're looking at. So a house, what characteristics of the house, or a building, temporal information, because obviously things are changing over time. So being able to look at how the data is changing over time. Data often includes raster data, so image data. Particularly today, you're looking at video, images, being able to try to blend that in, find attributes in that data. As I mentioned, it could be static or dynamic. It often is a moving vehicle, so you're looking at things that are moving, mobile devices, adding a lot of mobility to it. So you can imagine the sources can be quite varied. Volume is definitely rising, so it challenges organizations that are looking at traditional kinds of data management and data storage systems, and often is a reason why they're moving to the cloud, being able to take advantage of cloud storage. It adds location intelligence is powerful for analytics, and this is where the visualization often comes in. So visual location intelligence, answering spatial analysis questions to derive new insights, to get new perspectives on things, going beyond. And we see, I think initially a lot of business intelligence systems just sort of adding spatial, a mapping function to it, which was great in its time, was different. But now with spatial data science and using analytics, trying to get deeper than that and begin to plug it into other kinds of data and other data science that you have going on. And so really going beyond that sort of simple, just sort of integration and inclusion to really sort of deepen it and use it as part of your data science projects. So understanding what happened at the location, what's the impact related for geo-related entities. So you've got a lot of different equipment, vehicles, people, structures and things like that. What's the impact? What does it mean? And this is critical as I'm talking about digital transformation, business processes to improve efficiency and resilience. And seeing this really particularly in supply chain sort of scenarios where you're losing a supplier, so you need to pick up a different supplier or adjust the supply chain. And so this is very valuable information. It's obviously critical for retail, for real estate, to understand location, as everyone says, and then also just inventory where you have different supplies. In our research, 34% are making it easier, or it's important, is a key part of their strategy right now, to make it easier to discover data relationships in geospatial. So this is currently important, and 42% saying this is going to be important to their future. So they have really a plan already in place to incorporate geospatial data and analytics. As I mentioned, customer and market insights. I think we see some of the really top competitors out there looking at how this data it looks and how they can improve their marketing effectiveness, their messaging, to understand different kinds of segments that they didn't understand before, and then the competitive situations. And then to maximize, the other really reason is you've got a lot of new data coming in, and this is a way to integrate that data and make it relevant to the organization in terms of different types of decisions. Some of the challenges, really three basic ones, and of course a lot of things coming out of this, but scalability and speed of data access is critical for all kinds of data. But as you're adding new data, this typically slows down. So collecting and managing the new and larger data, such as spatial, is definitely a challenge. It's 33% saying it's one of their top challenge, or it is a challenge to collect and process geospatial data. Organizations, as I mentioned, are moving to the cloud for a lot of reasons, but one is really to be able to pull all this kind of data together. And a lot of organizations are using cloud data lakes, or moving to cloud data lakes, establishing them. And so we see in our research, 44% currently using and 28% planning to use. And this is above around the 30s. I think it was 31% using cloud data lake on premises. So you can see really, as we're moving forward, cloud data lakes is really often the choice for organizations, the first choice, and maybe with special considerations, they may need to have a data lake on premises. Cloud data warehouse, kind of the same thing, is moving to the cloud. 43% currently in the cloud, 31% plan to use. And again, this is above what we saw for on-premises data warehousing. So both of these systems are moving to the cloud. I think that we'll be talking about in this webinar, the data lakehouse concept and unifying the data is an important solution, because a lot of organizations are establishing several data warehouses, data marts, they've got the data lakes, and so the silo problem is becoming serious. So getting trusted and accurate data is one of the other challenges, and often this stems from silos that aren't really well integrated. There's a diversity of data, including global, particularly in geospatial. You're looking at addresses around the globe, all different kinds of formats, different quality with these addresses. And so having good data quality, again, one of those things that's important for everything, but for spatial data and geospatial data is becoming something that organizations need to overcome to really get best use out of it. And, a lot of data quality, transformation, those kinds of steps, data integration, enrichment, organizations are relying on legacy ETL, extract, transformation, and loading systems, or flipping the order to ELT once they may have a data platform in the cloud established that they want to use the processing there. So ETL takes a lot of expert programming to get the value, and it slows down the getting the value from these types of systems. So those are three big kind of buckets of really challenges that organizations are facing. So let's ask our audience, what are some of the challenges that you're looking at in trying to further spatial analysis and location intelligence for better business decisions? And so is it gaining buy-in? So getting buy-in from executives for investment and development. So this is often the case, as organizations can't really just get the executives behind it. So second would be having the right spatial analytics skills and training. So you need to kind of upskill the organization among both the data scientists and more tech-savvy business users to use it appropriately. Dependence on GIS experts and specialized programmers, not enough self-service for business users. So you want to extend out to business users and make it useful for them to interact with this data. But again, so they're not able to do it because of it seems too difficult. Data quality, consistency and accuracy concerns, or data management integration of large and diverse data needed for location intelligence. So a lot of these issues I mentioned in my slides. So let's take a look at what the results are here. And okay, so we can see that I wanted to also write down so we can refer to it later. So data management looks like the top one, so 35.1% saying that is the biggest issue. But we do see about a quarter, almost a quarter, 24.3% saying having the right skills in place, and then 13.5% each saying dependence on the experts. And so those kind of often kind of go together. Data quality, 13.5% is an issue. And then at the top here, we see 13.5% just gaining the executive buy-in. So yeah, you can see that here that it's really everything with the data management and integration of large and diverse data needed for location intelligence being the dominant one. So what are solution trends? So important solution trends for spatial analysis. One is addressing those data management issues really through a unified data architecture, and we'll be hearing more about this from Michael today with Databricks, the Databricks data lakehouse approach. And but this is definitely a trend that we see in our research. 33% here is saying this is very important to unify their data architecture, to bring the data lakes and data warehousing together for their current data strategy, and 44% for the future. What this can do, it streamlines the ability to analyze the new data and new data sets. So different, the the moving of the data, the extraction of the data, finding the data is less difficult, so you can perform spatial analysis directly on the system rather than having to often export it to a specialized platform, which is kind of like been the legacy way to do it. Ease of use and self-service are another important trend happening. They're looking at the powers of visualization, trends changing what's possible for visual data interaction. And again, as I mentioned, much more of an integrated and complete experience rather than kind of cobbled together. And this really enables the non-technical users. So as we saw in our research there that I think it was 13.5% wanting to move it out to more democratized and more other kinds of business users. This is the kind of thing that's important to grow that population of users who can work with geospatial data. So let's see, let me conclude with my presentation. We'll move on to the others and we'll talk more in our discussion session. Innovation. So think about innovating, what you can do next particularly as you're digitally transforming traditional systems using spatial analysis for clearer, more complete insights, particularly in areas of customer intelligence for marketing, sales, service, better engagement. So improving all these areas, targeting and segmentation, knowing where to invest for higher sales growth. This can be very helpful for that. And being proactive in location decisions is important. Situation awareness. So understanding data relationships. You have different types of data that are telling you these things, but often the location is what really kind of pulls it together and makes it make sense. So particularly around inventory, logistics, supply chain processes, but also in areas like healthcare with population health impact, people will see that more clearly. It ignites different ways of data science for tracking trends and patterns and predictive analysis. And finally, future-proofing. So future-proofing data analysis and self-service access, this is the kind of stuff that's going to grow in your organization. So having a unified architecture, beginning to reduce the data silos is important for making spatial data discovery and analysis more effective and complete. And then you want to be thinking about the front end to enable more types of users. So data visualization for faster insights by those democratized users is very important. Andrew, I'm going to hand it back to you at this time.
Terrific. Thank you so much, Dave, for that great presentation. A quick reminder to our audience, if you have a question, you can enter it at any time in the Ask a Question window. We will be answering audience questions in the final portion of our program. Our next speaker is Michael Johns with Databricks. Michael is one of the founding members of the Geospatial SME group at Databricks, where he has worked with a variety of spatial data and frameworks, offered thought leadership for current geospatial product and solution direction, authored content, and spoken at numerous Databricks-sponsored events. As a geospatial specialist, he is responsible for enabling and developing a team of strong subject matter experts. He also acts as a cross-functional representative with product management, product marketing, and engineering to package high-quality geospatial features and solution accelerators for their customers and partners. Welcome, Michael, and I will hand it over to you now. Michael, sorry to interrupt. I believe you're still on mute. If you want to go ahead and start from the top there. A quick browser refresh might actually solve the problem here, Michael. Bear with us here, folks. Slight technical issue.
Am I coming through now?
Yep. There you go. Go right ahead.
Okay. I think it was a browser refresh. Sorry about that. So I'm going to talk to you very briefly about a little bit about Databricks Lakehouse and how geospatial on the Lakehouse has some advantages. So this concept of a lakehouse may be familiar to some of you. It's really been an emerging category over the last few years. What we find at Databricks is that customers feel tension in what was mentioned before about data management, a lot of data. Increasingly, there's just data coming from every direction. Geospatial data within that is really across, really all industries. So customers find themselves with a lot of data, and they really have this kind of this tension between making investments in their data for various, further processing analysis that they have in mind. And really the bookends, if you look at the maybe not too subtle house picture on the left of the slide here, the left side of that picture is data warehousing, which is well established for various business kind of reporting, analysis, good structure to your data, the ability to build downstream clients off of the type of tables that you're producing in a data warehouse. And on the right side of the picture, you have more of a need of making investments in data and algorithms, frankly, and libraries that allow you to get deep into, say, predictive analysis of your data, even prescriptive analysis as you move further, and things like automated vehicles and things like that. And so both sides of the coin on the data warehouse, data lake side, the data science side, there's really a file-based construct and the need to iterate over your data quickly. And often there's going to be like unstructured data, semi-structured data that comes into the picture. So the Databricks Lakehouse really comes out of trying to reconcile, data warehousing and data lakes. And then when you look in the middle of the kind of the top part of the picture, you have data engineering and data streaming, which really go hand in glove with the need to get high data that came in various mixed quality into higher quality, and also handle higher speeds of data in a way that is reliable, secure, performant, and really with performant and reliability comes cost savings. So customers really want to save money. So Databricks has been at this for about 10 years total as a company. We're the original inventors of Apache Spark and come out of that, but we've definitely progressed a lot further. And so, moving kind of through this, we have the really the ability to take cheaper cloud object storage and be able to bring this data warehousing like experience and data lake like experience and blend them together with governance in our Unity Catalog product. And we really accomplished that through an open source table format called Delta Lake, which really does blend all these concepts together. So hopefully in the Q&A we can look at that further, but at the end of the day, we drive simplicity, so the ability to not have to really struggle with your data is one of our goals. We actually bring scalability at a reasonable cost, price performance for our customers. And we're also open in terms of no lock-in, built on open source in parts of what we do, but also open APIs, because we'll actually bring reliability beyond what open source offers. And we run on multiple clouds. So there's just a few slides here, but the geospatial on the Lakehouse, when you look at what we just talked about and you think about geospatial is really riding along with a lot of data, plus there are specific geospatial formats. And so from a data engineering or ingestion side, there's a lot of ways to get your data into a format into the Delta Lake format and other formats that bring high quality and allow you to get the value out of your data. And also the ability to introduce various solution accelerators for the various types of data that you have to help we do that to help our customers get up and running faster, to be able to learn from what other users have done, to not have to struggle as much, and then ultimately open up your use cases for various workloads that you're looking to accomplish. So just really briefly, Matt's going to go into this a lot more. But Databricks product in our platform itself, we've introduced H3 as an API that we support very, I would say, robustly through our Photon engine. There's the ability to run really efficient columnar level. So at the table level, you can run across an entire column of your data to be able to execute H3 APIs. And so I won't steal Matt's thunder, but part of that really has to do with the benefits of global grid indexing. Just one kind of thought on that is, in sort of traditional systems, indexing was really hidden. We think about like how a data warehouse handles indexing traditionally. You don't really work with the index itself. H3 really allows, through the global indexing, allows the index values itself to be elevated in your analysis and your processing, so that you can actually use the indexes themselves as a proxy to not even have to work with the underlying geospatial data, while not getting in your way when you choose to. And so there's a lot of flexibility that comes through the hierarchy of global grid indexes. And also when it comes to visualization, which CARTO and Matt are really great at, there's just a lot of advantages to drive scale around that. A lot of different industries, a lot of different use cases. I don't want to belabor for time, but there is a lot we could talk about where that can be used. On this slide, we'll let it build. But on this slide, we give a smattering of some of the kind of examples of customers and use cases that we bump into. So it's really, anything that deals with mobility, anything that deals with transportation, logistics. There's really like an unlimited amount when you get into things like routing, route optimization. Retail has a lot of interest, and then retail is always a proxy to financial interest. So for example, if you look in the middle of the screen with Thasos and customer success, they've built geofences around parking lots and buildings, and then they're using mobility data to understand when volume or lack of volume of foot traffic is entering various premises. And one thing I'll call out too, from an approximation perspective, the hexagons representing the H3 index space that's involved with each of the geofences for Thasos. The red is really the full index value that's within these polygons, but the blue is a precise option that you can use to be able to maintain precision in still using index space. And so there's some knobs you can turn for approximate and fast, or precise and still pretty fast in Databricks. So I'd be happy to discuss this more, but I wanted to give you a touch point on that. Very quickly, the platform itself introduces or offers a lot of flexibility, the Databricks platform. So you're going to have both your geospatial data and your non-geospatial data. You don't have to put them into separate systems with Databricks. And so, so you have the data part solved. We talked about that. And then you have this question of platform and flexibility. Databricks doesn't want to force you to do things one way. We want to make sure customers are doing what they need to do for success. Sometimes there's longer standing commitments that customers have, and we just want to, be able to work within what is required or needed by our customers. So there is a flexibility that comes with, with our platform. There's various open source libraries, there's various integrations and kind of a wide ecosystem of great capabilities that are out there. And of course, with CARTO, a very important partner of ours for a lot of interfacing with spatial data that Databricks has been prepared by our customers in Databricks. So I know Matt will get into a lot of it, but just the partnership and the power that CARTO offers on the Databricks platform drives just a lot of value and opportunity for our customers to both do what they want to do. Maybe without CARTO they couldn't do it, but also get the kind of the cost efficiencies that they're looking for as well. So with that, I'll stop and pass it back to Andrew.
Terrific. Thank you so much, Michael. Great presentation there. Allow me to introduce our next speaker. His name is Matthew Forrest, and he's the VP of Spatial Data Science at CARTO. He's also passionate about using and sharing ideas around modern GIS, helping others to use a variety of new tools in their geospatial workflows. Matthew graduated from the University of Wisconsin-Madison with a degree in geography and has been working with GIS and in geospatial for 11 years, the past 7 at CARTO. He has worked with businesses and governments of all sizes and scales and enjoys helping others advance their GIS careers. Please welcome Matthew, and I will hand it over to you now.
Great, thank you. And just to mic check, can everyone hear me all right?
Yep, coming through clear.
Perfect, all right. Well, thank you, and thanks for having me. I'm excited to be here and talk a little bit more about what we do at CARTO, how we integrate with Databricks, and how geospatial can be practiced in a modern data architecture in the data lakehouse infrastructure. Just a brief introduction to CARTO plus Databricks. CARTO is a geospatial platform, and what that means is that we effectively sit on top of data infrastructures like Databricks to provide tools to not only analyze your geospatial data, but share those insights, visualize them, and ultimately make them useful outside of the data environment themselves. So of course, when you think of geospatial data, you commonly think of maps or dashboards or interactivity like that. That's the problems that we solve, but we really try to solve them at scale with modern data architectures such as data warehouses and with much, much larger volumes of data that have not been traditionally achieved with other geospatial tools. So that's sort of our goal in terms of what we set out to do and how we do it. There's a few other pieces there that I'd also like to highlight. So the first thing I kind of mentioned is with connectivity. So we connect to Databricks and your data warehouse infrastructure natively. So effectively everything connects into the secure, data governed infrastructure that you've set up already in Databricks. There's no replication of data. You're not moving data in and out. We just connect to what you're already using. So that's a big advantage from an enterprise perspective that people really like. The second is sort of introducing other data. So of course, if you have a set of locations or areas that you want to study, there's probably some things that you want to know about that area. You might want to know the population or the median income. You may want to know other points of interest near that location. And of course, that's going to require other geospatial data that you may or may not have. So what we do is we also have a data catalog that's called the Data Observatory that brings you different data options, both premium data, which you can acquire, or public data, which you can use, such as the US Census or OpenStreetMap or data from NOAA and other areas that you can start using for free. There's two things you can do with that. You can combine that and query that alongside your spatial data. You can enrich it, and we provide a set of functions to do that, to actually enrich your data. And what I mean by that is to ask those questions I was talking about, is to say, what's the population within a 3-mile radius of this location? Things like that you can ask without having to write extra code or do anything special with that. Or you can take that data and visualize it and do other pieces with that. So it really becomes another tool to actually add value to your geospatial data that you have. The next is sort of accessibility. We try to make our tools as accessible for all the audiences to use and create spatial analysis, to visualize that data, and then to make it accessible and usable to wide sets of audiences. And the last is sort of an end-to-end offering that we have. We have tools for you to create ad hoc dashboards. We have tools for you to that embed into Databricks to add more spatial capability and analytics capabilities. We have tools for developers if you're building geospatial products or internal solutions that you want to build. And then you also have different tools for things like what we call location data services. Like if you have address data, we can geocode that data. So there's all these different pieces that are built into the platform. Now, all of that is summed up in what we call the spatial extension for Databricks. That's a platform that basically extends some of the functionality within Databricks to add spatial components to that. So that it could be other functions to work with, geometric data, other things like that that we can use to, sort of explore that. Like I said, that spatial extension is embedded directly within Databricks. So it runs everything in that same place, in that same security, and inherits all of that from that perspective. So that's kind of why we chose that route, is to bring and integrate into existing data infrastructures rather than asking you to bring your data somewhere else. I think that's an important call out. So how does this all work together? The best way you can kind of think about it is when we look at the Lakehouse platform here on the bottom, that pulls up into a layer of CARTO that has sort of these integral APIs. So that allows you to, when you push a query down from CARTO, that pushes directly down to Databricks, runs the analysis, and it pushes that back up to do visualization within the front-end tool. So there's some different pieces there. Once again, this runs on any cloud. Our platform, you can use our cloud service as a software as a service, or that can be directly installed within your environment in any cloud that you want as a self-hosted option. So all of that kind of integrates there. So there's that middle layer. If you kind of think this is a strange sandwich with your data on the bottom and the maps on the top, there's this little layer between that kind of does all the heavy lifting that translates back and forth between the two. There's no, like I said, no data moves back and forth. It's just sort of the queries, and then we get the visualization layer that we push up to that. But that all lives within your cloud alongside your Databricks and everything like that. There's 3 different front end tools that you would see your maps in. There's sort of ad hoc dashboarding, which is within your CARTO workspace that allows you to see where your data is, that allows you to query your data and ultimately create some dashboards in that in our product called Builder. There's solutions that we have verticalized specific solutions. There's different tools for consumer packaged goods, retail, out-of-home advertising, and others. And then the final is a developer toolkit if you're building your own geospatial tools that you want to add map layers to or things like that. That's another option that we have as well. So we've seen different customers who are using a variety of tools like Mapbox, and the data's gotten too large for that. You can certainly add those layers on top of those things in different areas too. Let's see here. So I really want to touch on this concept of the spatial indexes, and those are those little hexagons that you've seen before. The one that we have and integrated with Databricks is called H3, and this is actually a open source tool that was originally developed by Uber. If you've ever sat in the back of an Uber and seen the driver try to find their next area to go to, they actually use H3s to look at demand, but they use it to mask and anonymize the actual pickup locations of everybody that's trying to get picked up. So there's three major advantages when we look at using H3 or spatial indexes at scale. The first is that there's visualization and approachability. The next is scale and performance. You get a massive performance boost when you migrate to an H3 or spatial index infrastructure. And then analytics. There's a different sort of parent-child mapping and neighbor analysis that you can run with H3s that's naturally built into the way that the H3 system works. Now, spatial indexes at their core are what's known as a global discrete grid system. So this is a grid system that covers the entirety of the globe, and there's different methods that you can choose. So H3 is one that we kind of prefer because there's a very clear parent-child relationship between all of them. The border effects are pretty natural, and the distances between the cells is also common and the same for every single one. The last is that the cells are the same area no matter where you are on the globe. So as you may or may not be aware, the maps that you see from Google and others have a distorted view to project them onto the web. H3 sort of accommodates for that and keeps the area the same no matter where you are. So the first is about performance and how you kind of have to think and change your thinking about geometric data. So if you think compared to a geometry, this would be a polygon that's made up of points. These are latitudes and longitudes, and that data can be quite large if you think of it that way, especially if the geometries get very, very complex. A point data could be much larger and complex as well, no matter if you're storing these as true geometries or as what's known as well-known text. The data gets much larger, so that's one common challenge. A spatial index is just and the H3 sort of system is just these few digits here. So it's the 15 length alphanumeric code, and what that effectively represents is a specific hexagon at a specific level of granularity somewhere in the globe, right? So what you're storing here is not geometric data, it's just this alphanumeric string. So it's kind of a strange way to think about that in reality, but when you pivot to that thinking, you're gonna save, first of all, space within your data storage. That's one key advantage. The bigger advantage actually comes when you look at performance. So this is some simple analysis we did taking rasterized telecommunications coverage data. So this is basically if you go on any of your telco coverages, they produce maps that show you where their service is really good or where there's gaps in the service. They have the same type of data, but it actually gives you the service strength that they use internally. When we did that, we took that rasterized data and turned it to geometries and did some simple spatial joins just to say, okay, over the entire country, what's the coverage in these areas, average, min, max, and what's the population in those areas. There was massive gains in sort of processing time. When we look at a spatial join, it went from 12 days to 7 hours, right? So this is a pretty massive sort of increase. We're talking, data transferred, it went from 4 terabytes to 1.5 terabytes. The RAM to process the file went down significantly. And when you specifically look at the time to process a spatial join with population, I think that's one of the most dramatic things here is basically going from a spatial join that takes 26 minutes down to 3 seconds, right? It's just a massive performance. And then ultimately, when you look at coverage loss, because you're moving from a pure geometry down to a hexagon, there's really no sort of loss to, 2 decimals out, in terms of the total population. So you're really not losing a lot of data there, which is a really great advantage as well. But ultimately, what does that boil down to in terms of reduction of the, the cost in the data warehouse? That's another big, kind of performance that you can store a lot more data, right? So you're going to query it faster, store it, and ultimately gain that boost in performance in terms of insights. Now, in terms of visualizations, this is another key advantage. This is on the left-hand side, you're seeing data in London that is stored at a census geometry. And census geometries can be very strange in shape because they follow roads or sort of patterns that might be difficult to kind of comprehend or work with when you think of it that way. So how do you kind of make sense of this? Of course, this is population data. So you can see there's areas that have higher or lower densities of population based on the census data. Something on the right visually makes maybe it's a little bit more intuitive to understand those groups together because you're looking at a common space over time. So if you're taking this data and sharing it with someone who's never seen that before, this is a much more approachable visualization on the right to understand, comprehend, and start to wrap your head around geospatial data. So when you take this data out to stakeholders that may not be familiar with maps and things like that, this is a really great way for them to approach that. So the other component is the visualization scale. Now, when I said that 15 length alphanumeric string represents a specific cell at a specific point on Earth, we know that that's consistent everywhere we go. So we can store and create these hexagons through our Maps API, and they're never going to change, right? They're always there. It's a global discrete grid. So effectively, what you can do is pass much more massive data sets to the front end to visualize. And this is a 73 gigabyte data set that's being visualized live, right? This is a tile set, if you're familiar with the term, that we can visualize. Now, if you try to visualize that amount of data with pure points or geometries, it would be much, much slower, if not impossible to do so. But since we already know those geometries exist in specific ways and locations, we can do that right away. Now, if you're interested in learning more, there's actually, you can go to our website and find this report around spatial indexes 101. This is a great place to get started. Obviously, we integrate this directly into Databricks. Like I said, you can do this today with all the processing and start using that and visualizing that right away. So, you know, this is a great place to understand more about this, but then also translate that into your Databricks environment and get going from there. So there's one other piece I want to call out, which is another effort that we're working on. That's an open source tool that's called GeoParquet. So if you're familiar with the Parquet, you know, Parquet, you know, file format, highly efficient, especially when you're talking about a, you know, sort of a lake house infrastructure. Now, Parquet did not natively support the geometry data type. And this is something that we're working to support, to be able to take advantage of that very fast and advantageous file type, but add the geometric support for that. There's lots of people that are sort of working under this under the umbrella of the Open Geospatial Consortium. And what we're able to do is actually, you know, basically bring the geometry into a lakehouse environment where we can have a data lake that has, you know, Parquet or GeoParquet files, query them from these different tools and process them at scale. So it's a much, you know, better way to do this. In addition, it extrapolates or removes some of the complexity with ETLs, right? If you have a GeoParquet, you can dump that into your lakehouse and start querying it right away, rather than doing a lot of ETL or transformations there. This is a really huge advantage and something we're really looking forward to push forward to make geospatial a lot more accessible.
All right. Well, thank you so much.
Yeah. Oh, go ahead.
Yeah, terrific. Terrific. Yeah, no worries, Matt. Thank you so much for that presentation. It is now time for the roundtable discussion, as you can see. So I'll ask that Dave and Michael both rejoin us, and I will pass it to Dave to begin the discussion.
Thanks, Andrew. Really interesting presentations by both of you. So let's discuss some of these things. The first is just what are opportunities you see for spatial analysis? I mean, I think, Matt, you did a great job talking about some new technologies that are happening. So there's some things that people couldn't do before, which took too long, which are easier now. So maybe we could just talk about some things you're seeing in your user base, what opportunities to solve business questions and new requirements. Matt, do you want to go first?
Yeah, I think, you know, there's a lot of, you can kind of look at any space or industry and find a use case for geospatial, right? So, you know, to go into every single one right now, we could spend days talking about it. Yeah, but I think new opportunities, ones that we're really seeing pop up, you know, there's definitely areas around understanding CPG product rollouts and how that integrates with retail, especially in this sort of economic environment where there's inflation and changes there. Certainly people's buying patterns are going to change and adjust, and how can we get a real good grasp on that, not just at the product level, but then on the geographic level as well? Is that changing by geography? Are there different preferences in different areas? And how can we adjust to that? Same sort of goes for supply chain and logistics. Is everything kind of got upended, and we're still seeing these pockets of product gaps and outages in certain stores where things are going from completely available to unavailable and stuff like that. So understanding geographically where that is another great point. And I would say the last is sort of around climate change and resilience is a huge area, and all of that all resolves around geospatial data. So where are there issues currently, and where are there sort of warnings and things we want to watch out for, but how can we plan forward to understand what that's going to look like in 25, 50, 100 years to make resilient choices, no matter if we're within the government space or outside of it.
Yeah, it does seem like it'll be absolutely critical for those areas. Michael, did you have anything you wanted to add to that?
Yeah, I would add that we definitely see opportunities around things that used to be in the realm of GIS experts. Is still very, very valid. Of course, that's an honored sort of career and focus area for so many people. But it can also be daunting. I mean, geospatial is a wide surface area, and so being able to bridge into different personas to maybe lower the threshold of what you have to know as, say, a data engineer to be able to handle streaming data that happens to have geospatial as a component. There's already a lot that a data engineer knows. And so kind of removing some of the specialization requirements to be able to work with the data does open up a lot of opportunities for business questions. At the end of that chain, kind of naturally is when you get into reporting and dashboarding, and of course map interfaces can be very intuitive as well, especially the way CARTO does it. So the ability to kind of unlock for maybe more of a SQL or a visual interface persona is really where I think geospatial has struggled in the past. So it's exciting to be able to unlock more for users.
Yeah, it does seem like geospatial has kind of been over in its own little area, which there was amazing things that have happened, but it makes it difficult to integrate with others. So maybe the second question, we're talking about how technology for spatial analysis has been evolving, both for users and management. What are some recent developments? I think you both talked about H3. I don't know if there's much more to say about that, but how you think that might develop, and then anything else that you might want to mention. Michael, maybe you want to hit that one first.
Sure. Yeah. So, I mean, Databricks has been really involved with a lot of transformation. I'd say we've been riding the wave of just a lot of how technology has been transforming. The economies of scale that the cloud introduces does create this need to, things that run on, say, a laptop or a single server just no longer are enough. And so distributed systems and sort of how to manage cost and performance is just really important. So what we see, we see this increase as industry technology, vendors and platforms have been tackling these problems. We're still kind of feeding this never-ending set of potential use cases that customers and users come up with or would like to accomplish, things they couldn't do 10 years ago that were really unthinkable for even things that involve GPU or, just kind of the cost. You couldn't kind of stand up your own data center. So what we see today is really the more that we lower the threshold of what's required to be able to there's fewer barriers to entry to do more advanced analysis. So we do find that there's an appetite for, advanced spatial, various, advanced routing, various, modeling when you get into things like climate, terrain, flood risk. There's just a higher appetite. that we can actually meet and kind of help bridge the expertise required. So Databricks definitely sits in a lot of that. And like when you think about spatial AI, spatial ML, kind of object detection and context, and various iterative algorithmic based needs that customers have, that's an exciting area that we talk to customers about.
Mm-hmm. Matt, did you have anything you want to chime in on there?
Yeah, I totally agree. I mean, when we talk about, GIS and broadly sort of geospatial as a practice, some of the things we brought up, it's kind of traditionally the data's been siloed, and these modern data infrastructures have kind of been a few years ahead of where geospatial is, right? We always are in the geospatial space playing a little bit of catch up as we go. I've heard estimates anywhere from like 3 years behind to 8 years behind, but I think that's generally what it looks like. So our goal is to kind of accelerate that as much as possible to play catch up to these amazing tools that are being used and leveraged. So when we talk about that, it's how do we make that as accessible to the widest audience to use, both if you have geospatial expertise or if you do not. And like I said, H3 provides a really good method to do that. Anyone who's working in geo can kind of understand a hexagonal grid across the globe. If you're a data engineer, it's pretty easy to translate your data to H3, adding a few simple functions into your pipeline. H3 is an open source library that works with just about any language you might want to use. So you can easily do that. And then for people who are generally working in data as a data scientist or a data analyst, it's pretty easy to group or aggregate by the string type, and there's sets of functions that you can use to do that. So you can do this analysis very quickly with this sort of spatial index, and it sort of democratizes the access to the data a little bit, rather than having to learn a complete set of how to do a spatial join or overlaps or all these other kind of geospatial analytics tools that in the GIS space people have known for a long time, but we want to make that more accessible to a broader audience of data scientists and data engineers and data analysts. So
do you see that you mentioned the translate to H3, just the migration from older systems to H3, is that something you see organizations doing right now, and is it difficult? And what's some thoughts on that?
Yeah, it's especially if you're in like a sort of a traditional data stack, if you think of it that way. There's two. I think one is if you're in a traditional GIS data environment, you might have data that is raster vector, and there's different translation tools to bring those and translate into H3s. So that's one sort of migration, right? And where does that data land? It either lands in a data lake, or and eventually in a data warehouse. But I think what's also important to call out is data that your existing location data that might be in your data infrastructure. You may not have it as a geometric store, but you may have data with latitudes and longitudes that just kind of sitting there, right? And taking advantage of that. Also, there's lots of location data that's just stored in things like addresses or strings or stuff like that. And how can you translate that data and make it useful from a geospatial perspective? So there's kind of this, all the migration problems that you see from whether that's on-prem or other architectures, you kind of have that problem, but then, making that as easy to leverage that location data is kind of our kind of, like I said, our goal with that. So yeah, same types of problems, but, once those tools are there, it's fairly easy to start to move into that. So.
Okay.
Can I add one thing on that?
Yep.
Just to kind of say from what we experience is a lot of times customers are making a journey into the cloud. It's an ongoing process for who's where in their journey. And so a lot of times they're saying, they're coming from a traditional data warehouse paradigm, and they may only have a category that says, we've got this management that's telling us that we have to get ported, migrated over to the cloud, and we really can't touch any code, any sort of queries that we're running. We have, kind of fixed business logic. But we also have this idea of future expansion once we get into the cloud. And that does become kind of a difficult conversation, because I don't know that organizations set up themselves well to actually reimagine what it means to go to the cloud and the new potential that's unlocked by going to the cloud. And so we often find ourselves trying to figure out, like, well, are you just going to get kind of locked in with, like, you're doing the same thing you did on-prem now that you're in the cloud? and you really are going to need to re-architect at some point to be able to open up for these new use cases. Is this just technical debt that you're kicking down the road? Wouldn't it be this be a better time, because your current system probably can still do the vast majority of what you're asking it to do today? Maybe reimagine, when you go to the cloud, to also modernize your architecture and your approach so that you land in the cloud with advantages, not still 5 years behind your competitors. So we have a lot of those conversations, and it is kind of hard because there's a lot going on at once when organizations are going through these types of changes. It's hard to kind of help them understand where they want to land while they're just trying to figure out some of the early steps. But looking over the horizon, I think, is the most innovative and sort of long-term companies that find the most advantages do find ways to kind of see where things are going and how do they sort of angle ahead of just the immediate steps to make sure they land somewhere that's competitive.
Yeah, those are really good points. So also in the big area of change management, I guess you could say, because there's so many considerations. I want to make sure we have enough time for audience questions, but how do Databricks and CARTO work? You guys hit that in both of your presentations, but maybe there's some case examples or some other depth you might want to mention there. Michael, you want to go first on that one?
Yeah, so obviously we have the extension for the Databricks Spatial extension for CARTO. We have the in line with our notebooks. There's CARTO integration to be able to render directly in our notebooks, and so really customers that are wanting to run scaled analysis, they really need CARTO to do that well. I think with Databricks, they're going to need a partner today to run scaled visual analysis. And so I think the use cases are kind of things we've hit already. There's just various things around, everything from sort of, things that deal with demographics or attributes about an area, through to various routing considerations, logistics, climate change. There's a lot of ability to average over different areas to kind of understand what's going on in a particular part of the world. It's hard to kind of get into all of it, but there is a kind of a wide ranging, but CARTO at the front end of being able to render that for customers is just really important.
Great. Well, maybe before we hit that last question, I think we'll get some other kind of more practice questions from our audience. So let's move to that now. Andrew, maybe I'll hand it back to you for those questions.
Yeah, definitely. Thank you for the great discussion, everybody. We'll jump into the audience Q&A here. So first question will be directed towards you, Michael, but Matthew or David, if you have any additions to what Michael might say, please offer them up. So Michael, for you, what team size and roles do you need to support a spatial team for the enterprise?
Yeah, that's a good question. Really, it really comes down to what's the special skill in the question, which could be different, right? Because if you're trying to build, say, a predictive model for predicting traffic patterns to understand, something that affects either, say you're trying to do a site selection for a store, and you really want to understand, what will be the traffic patterns to make sure my store's in the right location. That's bringing together a lot of advanced machine learning expertise. And so if you want to get into advanced machine learning, that's going to require kind of specifically knowing how to grow that skill set. If you have the other skills, I think are more readily found because like I mentioned earlier in my slides, if you have a data engineer today, that data engineer could turn their attention to kind of guided ways to process geospatial data without it being some very exotic thing they have to do. So I think on the data engineering side, that's probably the most easily portable if they're doing something today with data engineering in the cloud, I would say. then you have an easy ability to extend skills to say, look, here's the best way to help, get it into a format that you can then get the value out of it. And I think your data analyst, really the friction or the kind of barrier goes down when you introduce this global grid indexing. They no longer have to be as versed in sort of, spatial temporal functions, even for spatial SQL. Those are very important, and it's not that hard to kind of go there. But even just working with the index, the global grid index itself, if they're at all familiar with SQL, or other programming languages, but with SQL, they're able to do things like group by clauses in SQL, and then the cell ID becomes the group by that they're using. And so they're able to run all kinds of SQL-based analysis that's basically proxied by the grid index instead of having to even go to the full spatial temporal function. So I would say it's a spectrum. It's not like you want to stop at one place, but I would mostly be looking at how to up-level existing skills. Employees and companies want to grow in their skill sets. Nobody wants to show up and be less smart 5 years later at a company than they were when they walked in the door. So I think looking for ways to up-level your employees, kind of extend their current skill sets. But I do think data engineering is going to be important. Somebody has to do it. If you have spatial, if you have AI, ML, you need to think about how machine learning is going to happen. Databricks has citizen data science tools, but that won't take you all the way. And then in the middle, there's like the data analyst who could become a geospatial data analyst with just a little bit of focus and sort of investment. So the team sizes are really going to matter on how sophisticated what you're trying to accomplish is, I would say.
Terrific. Thank you very much for that answer. Moving over to the next question here, Matthew, this one will be for you. Is it possible to utilize custom defined inputs with H3?
Yeah, I mean, depending on when you're talking about custom defined inputs, H3 there's a lot of different functions that you can use. So the most basic one is taking latitude and longitude and then defining the H3s as an output. You can also do what's known as a polyfill, so filling in a geometry with an appropriate amount of H3s. You can do them based on size and scale. And then H3s allows you to basically look at neighbors and what we call K-rings. So if you want to find the neighboring rings that go to 1, 2, 3, 4, however many levels, you can look at parent and child relationships. So, each H3 cell has 7 cells that fall within it, and you can map up and down from there, which is actually how we do the live aggregations in our platform, so we can actually live aggregate the visualizations that you see. So that's kind of the core inputs that go into an H3. It has to be some sort of geometric data, but you can use those functions to sort of define what you want to get out of that. And excuse me, when we're talking about sort of a data engineering pipeline or something like that, that's a great way to kind of get started to put into those. So.
Fantastic. Well, there is a significant number of questions here. Unfortunately, we won't be able to get to any more. We have run out of our time today. We will do our best to get these questions out to both Matthew and Michael, and perhaps they may be able to take some time and answer these offline for those that asked. We do appreciate all your participation in today's webinar. But please allow me to thank our speakers today. We did hear from Dave Stoddard with TDWI, Michael Johns with Databricks, and Matthew Forrest with CARTO. Please also allow me to thank Databricks and CARTO for sponsoring today's webinar. And please remember that we did record today's webinar and we'll be emailing you a link to an archived version of the presentation, which you can feel free to share with colleagues. Also, don't forget, if you'd like a copy of today's presentation, you can locate the resource window at the bottom right of your console. In addition, you can learn more about spatial data and many other topics at TDWI Las Vegas, which is in February 12th through the 17th. TDWI events aren't like other conferences. You can attend full-day and half-day courses with our vetted instructors, ask questions, earn certificates, and CPE credits. If you haven't registered yet, you can save 30% off your full-price registration with the code WEBINAR today. We hope to see you there. Please visit tdwi.org/Las Vegas to learn more and to view the agenda. Lastly, here from all of us, let me say thank you so much for attending. This does conclude today's event.